Hello and welcome, my dear students and viewers, to my channel Mathematics Made Easy. This is Miss Ruchika welcoming you all to today's session for grade 10 elite students. This is the last lesson of module 7 that we have started, which was matrices. So today we are covering the last lesson, lesson 7.7, and this is part 1 of the lesson, which is solving system of equations using inverse matrices. In today's video we are going to see how we find inverse of a 2 cross 2 matrix, and we are going to use the identity matrix for doing so. So let's get into the video, and I request you to watch the video till the end so that you understand the concept of inverse of 2 cross 2 matrix and know how to find and solve problems on this topic. So let's get to know what is the identity matrix first of all. So there are different types of identity matrix which are possible. The first type is the 2 cross 2, which has 2 rows, 2 columns, as you can see here. And the second one is 3 cross 3, which has 3 rows, 1, 2, 3, and 3 columns, 1, 2, 3. Remember, rows are horizontal, R1, R2, R3. Columns are vertical, C1, C2, C3. Now, how is this identity matrix defined? As you notice, there is a pattern. If you look at the 2 cross 2 matrix, this is the main primary diagonal. So the primary diagonal has always element 1, and the secondary diagonal, I'm going to change color and mark here with blue, has element 0. So this is the definition of an identity matrix. Let's check the condition here for a 3 cross 3. So this is the primary diagonal. The elements at the position: first row first column, second row second column, third row third column, where the row and the column number are equal. This is primary diagonal. And if you see all other elements, 0, 0, 0, 0 and 0. So yes, these are two well defined identity matrix. And in order to fulfill our learning objective for today's video, which is to find the inverse of a 2 cross 2 matrix, we are going to be using this identity matrix. So it's pretty important. Let's see now how we use it for finding inverse. Okay, so before we get on to inverse, just to give you a proper definition, which is given in your math book also, for the definition of an identity matrix. See, identity matrix we are going to use for the operation of multiplication, and by definition of an identity. Now, even if you go back and remember your basic numbers, then identity number was that number which when multiplied to a given number gives the same number. So that is the same concept extended to matrices. So identity matrix for multiplication, you generally denote it with a capital I. Okay, so capital I denotes your identity matrix. This is how you use the symbol, the alphabet I, capital I, to denote it, to write it, the symbol. It's a square matrix definitely. So either it is 2 cross 2 or 3 cross 3, where 1 is the number present at the main diagonal, as you just saw in the last slide, and from the upper left to the lower right, at all other positions you have 0 element. So if you see, by definition of a square matrix A, if you have the identity matrix and any other square matrix, like for example you have this 2 cross 2 matrix which has ABCD, some general elements, then by definition A multiplied with I is equal to I multiplied with A, equal to the same element. So the definition of identity matrix here is that it is that matrix I which when multiplied to any 2 cross 2 matrix ABCD, A matrix here, will give you the same matrix. Okay, so this is the definition of an identity matrix. Okay, now let's see what is the condition that will help us to find the inverse. So this is a condition which you need to check whenever you get a question on verifying matrices. So generally one matrix will be given to you like a matrix B. So one matrix, say matrix A, is given to you, and another matrix also is given, matrix B. So you'll get a question in your ministry exam to check whether A and B are inverse matrices. So you have to check those answer can be yes or it can be no. So what is the condition? Very, very important that you will check. So if you have two n cross n matrix, so we are talking about square matrices only, we are finding inverse for such matrices. If the product is an identity matrix, means what? If the first matrix is A, second is B, and their product A multiplied with B is identity, which is also equal to, even if we change the order, B multiplied with A. So here first A is multiplied to B, here B is multiplied to A. So whichever order you follow, if the product is equal to the identity matrix, and we are talking about 2 cross 2 here, so in that case you would say yes, they are inverse. So yes, they will be inverse. That you will check. And what about the case if the product is not equal to identity? In that case, definitely no, they are not inverse. So that's what you will check. That's the kind of first question to expect in your exams. And we are using the key concept here that if matrix A has a inverse, yeah, another important point, A inverse, A to the power minus 1. This is how you write, this is the notation, the symbol for denoting inverse of matrix A. Okay, so you put a negative 1 on top. So A multiplied with A inverse is equal to A inverse multiplied A equal to the identity. So this is the basic condition, the definition of inverse, and we'll use this condition now to solve some problems. So this is one kind of problem where you need to verify inverse matrices. So as I told you, two matrices A and B will be given and you have to check, you have to determine whether they are inverse or not. So you have to, that means, do their multiplication, A multiplied with B, and also you have to do B multiplied with A, and you have to check, is this equal to identity? You are not sure till now, you have to check. If yes, it becomes inverse. If no, it is not inverse. So let's find the product of A and B. This is the condition we are checking. So A multiplied with B. I hope you remember matrix multiplication. If not, I will put the link in the description box to my video for matrix multiplication, and I want you to recall that when we are multiplying, we take the first row of the first matrix with the first column, and that gives you the first element. So negative 4 multiplied with, let me just add one step here. Okay, so negative 4 multiplied with 1 by 4 plus 2 multiplied with 1 by 2. So that's your first element. Now I need the next element, means first row, second column. So I'm going to change color. First row, second column. So what element it will be? Negative 4 times negative half plus 2 times negative 1. Again, next element, second row, first column. So negative 2 times 1 by 4 plus 1 times 1 by 2. Last one is the second row, second column. So negative 2 times 1 by 2 with a negative sign plus 1 times minus 1. So just simplify this and it will come out to be, on simplification, a zero matrix. Remember, a zero matrix is a matrix which has all elements 0. This is definitely not equal to identity, because for identity, just to clarify, you should have element 1 on the primary diagonal and 0 otherwise. So this is different. So they are not inverse since the product is not equal to identity matrix. Now we'll consider a case where the product is actually identity matrix, so the given matrices will be inverse. You can check similarly for matrix F and G. If you take the product of F and G, it comes out to be identity, and if you take the product of G with F, so you just change the order, first G then F, it is also same. So just remember, if in case you get the first product as identity, you need to check for second also by changing order. But if in case the product of any one order is not equal to identity, then there is no need to check for the other one. It will not be inverse. So here both are equal and they are equal to identity. So they are inverse. So that completes some solved example. Let's now solve a question together step by step. This question, it's a guided practice unsolved question I've taken from your book. You see here the matrix X and Y are given to you, and you need to check whether they are inverse or not. So what is the condition? Let's write the condition first that we are aiming at. The condition is if they are inverse, then their product should be equal to identity and the order can also be changed. Okay, so we'll first find x multiplied with y. Let's divide the sheet into two parts. Then we will multiply y with x, so we'll change order and see, and then let's see if this comes out to be identity or not. So let's write the two matrices. I want you to observe the difference. So when I'm doing product x multiplied with y, x is coming first, followed by y after it. Okay, and however the difference in here for y with x is first your y matrix is going to come. So I've just changed the color to make you realize of the difference, multiplied with the first one, 4, 2, minus 1, minus 2. Okay, so let's start with the multiplication. So these are 2 cross 2 matrix, so the result will also be 2 cross 2. So we need this element, this element, this element, this element. We've made the boxes, we've made the blanks so that we know what element has to come. So this position is first row, first column. So first row with first column. So 4 with 1 by 3. I'm quite confident that now with practice you are confident in matrix multiplication. So let's do it quickly. 4 multiplied with negative 1 by 6 plus minus 1 multiplied with minus 2 by 3. For this one you have 2 with 1 by 3. If you have any confusion still about matrix multiplication, do refer to my previous video. I have an entire playlist made on matrices, especially for all of you to get the benefit. So please do check it out. Okay, now what do we get from here? 4 minus 1 by 3. 4 minus 1 by 3. From here it is 0. From here also, let's see, again 0. From here we have negative 2 by 6 minus 4 by 3, and it is positive. Okay, so just let's simplify this little bit more, and this comes out to be an identity matrix. So looks like it is going to be inverses of each other, but let's just verify from the second part also. We can't be sure till we find this. So this row with this column gives you 1 by 3 with 4 plus minus 1 by 6 with 2, that's the first element. Then 1 by 3 with 4 plus minus 1 by 6 with minus 1. 1 by 3 with 4 plus minus 2 by 3 with 2. And last but not the least, 1 by 3 with minus 1 plus 2 times 2 by 3. Okay, so let's simplify again. So this is 4 divided by 3 minus 1 divided by 3. This is actually 0. What about this? Let's see. So for this element, you had taken 1 by 6 with negative 2. So yes, again, this is also 0. And for this one, minus 1 by 3 plus 4 by 3. So 1. Oh yes, this is also identity. So both are equal. This is also identity. This is also identity. So is the condition true? Yes. So they are going to be inverses of each other. Now that we have solved a complete question together, I hope you are more comfortable and you understand how to find the inverses, how to check the condition. Okay, so now you know how to check and how to verify that a given two matrices are inverse of each other. So let's proceed further and find the inverse of a 2 cross 2 matrix. So this is a key concept, very important. So the rule, it's like a shortcut that works. In order to find the inverse of a matrix, step 1 that you do is to find its determinant. So determinant of A should be non-zero in order for this matrix to have an inverse. So your matrix A is A, B, C, D. So let's see what is its determinant. Its determinant would be A, B, C, D with the determinant. So the rule is primary diagonal minus secondary. So AD minus BC. So this AD minus BC has to be non-zero. That's condition 1. If this step is not true, you cannot find inverse. So first you check this condition. After you do this, step 2 is to apply the formula. And the formula says in simple words that A inverse, the inverse matrix is 1 over determinant of A times the other matrix which you get from here. So what do? You flip the diagonal elements, you change their position. So A comes here, D comes here, and the non-primary diagonal element just change the sign. So if B is positive, minus B, if C is positive, minus C. So that's a shortcut, that's a formula that you use to quickly get your inverse for 2 cross 2 matrix. Okay, so let's have an example for finding the inverse. It is a 2 cross 2 matrix. So step 1 is to find determinant. So determinant is 7 multiplied with -1, -7, minus of -10, which is 3. So it is non-zero. Since the determinant is not 0, we know inverse exists. So we use the formula. I have just put it here for you. 1 over determinant, so it is 1 over 3. You can just skip this step, no need. It's given one extra step in your book because you've already got determinant, so 1 over 3 you can directly come. And then for the diagonal element, you switch their places, so -1 and 7 here. And the remaining element change your sign. So if -5 is there, it becomes +5. If +2 is there, it becomes -2. Now this is just like scalar multiplication. So the scalar 1 by 3 is going to be multiplied to each element. It is going to distribute and multiply to each element, and this is what is your inverse in that case. Okay, so after you have applied the shortcut and you found your inverse, it's a good practice to check your solution before you submit your final answer, especially in an exam which is graded. So in order to check, what you'll do, the given matrix in the question multiplied with the inverse that you got, you'll see whether it is coming equal to identity or not. So if the product, the condition that you already know, is coming out to be identity, A multiplied with B is identity, you know your answer is correct, and then these two are the inverses. Let's look at another example. So if you have a matrix where you find determinant as step 1, but that determinant itself comes out to be 0, then you stop. You just say that Q inverse does not exist and there's no further need to solve the question. You stop there and give your answer as determinant 0 means Q inverse does not exist. Okay, so let's solve some questions now. So this one let's do together, and this one you can try yourself. So I'm going to do the first one for you. Let's call this matrix as matrix A. So for this matrix, step 1 is to find the determinant. So we convert to the determinant form, and we try to find its determinant by multiplying primary minus secondary. So 3 times -4 minus times 7. So definitely this is not equal to 0, it's -19. So we know that A inverse, or the inverse of the given matrix A, does exist. Okay, so let's find it now. It's very simple using the shortcut. So I'm going to use this formula sheet. It says 1 over determinant of A, so which I've already got 19, and then it says you take the matrix, just flip the elements in the primary diagonal. So -4 comes here, 3 comes here, and change the sign of the other two elements. So 7 becomes -7, 1 becomes -1. Now one more step will be added, which is the scalar multiplication. So let's do that one. So 1 over -19 is multiplied to each element. That means this becomes 4 over 19, this becomes 1 over 19, this becomes 7 over 19, and this becomes -3 over 19. Now they don't have any common factors, so you can leave your answer like that. And yes, you can check also, it's the correct answer. Do try to be, and in that case, you'll be getting your inverse as this one. You can check your answer. So that completes our today's session. And in this session, we have done how to find the inverse of a 2 cross 2 matrix. Hope you found the video useful. And if you did, do press that thumbs up, that like button, and share and subscribe to my channel. This is Mr. Chika signing off from today's session. Stay glued for the last video, which is part 2 of this lesson, and the last video of the series of matrices, where we are going to be solving important application of solving the matrix equation. Bye bye.